I'd like to welcome you all to the last Water Talk seminar of the semester. Appreciate your diligent attendance, those of you who have to be here to get credit and so forth, and the rest of you for coming today. Our speaker is Larry Adler, who's a PhD candidate in the Department of Economics here at the University of Wyoming. Larry has a BA from the University of New Mexico and an MA from the University of Colorado at Boulder, both in economics, and he's done quite a bit of research in water resource economics with such notables in the field as his chairman, Ralph Darge, as well as Ron Cummings and David Brookshire. David from our economics department, Ron Cummings from the University of New Mexico. His topic today, which I presume is largely related to his thesis research, is an economic analysis of water resource development in Wyoming. Larry, welcome to Water Talk.
Okay, thank you, Stephen. As is well known, during the past decade, several events have occurred which have forced western states such as Wyoming to take a more active role in developing water resources. These include, but are not limited to, the well-publicized changing federal role in development assistance. I say changing because although usually referred to as declining, the only thing that's declining is federal funding. Federal regulation seems to be on the increase, so we can call it a changing federal role. And there's been an increase in competition for the highly limited and scarce surface supplies. This has become certainly more important, and people have become more aware of this over recent years, especially with drought. Increasing problems concerning water quality and the changing composition of water demand. This is especially the case in the recreational sector. Recreation demand seems to be increasing quite dramatically. What this tends to do, or is likely to happen from this, is a heightened confusion and conflict between in-stream and off-stream water uses. Now, if we can conceive of surface water as an economic good, which provides or generates a flow of services to individual residents of the state as well as to the state as a whole, then it is clear that this increasing competition for those services requires a sound methodology for assessing development alternatives, something that addresses this issue, if you will. The problems arise here, of course, in analyzing an objective for water development in Wyoming. The focus for an economist or an economic analysis of water development in Wyoming then is to identify all values generated by water which may be affected by reallocation, and to derive conditions institutionally, culturally, and legally necessary for optimal and efficient allocations among uses. Okay, this changing cultural and institutional scenario has resulted in, for instance, an increase in in-stream flow demands over recent years. Unfortunately, this changing focus on demand poses some serious problems and questions for economic theory as a whole and how that theory is applied. And what we want to do today is discuss some of the implications involved here when allocating in-stream flows. Specifically, the traditional benefit cost analysis as it is applied, with an emphasis on market efficiency or economic efficiency, is probably not appropriate at the state or local level. Especially the assumptions of incidence neutrality is probably one of the bigger problems. Area of origin concerns, this type of thing. We need a framework or a methodology for assessing these impacts that go beyond just identifying economic efficiency impacts. And specifically, I think generally we can define at least or identify at least 3 areas of traditional benefit cost analysis which need expanding at least in order to accommodate the issues of in-stream flow. Traditional framework does not address in-stream flow in a very efficient manner. First of all, what we could call area of origin concerns. The incidence neutrality assumption is, of course, not appropriate at the state level. Adverse impacts from a national perspective can be expected to net out, and this is certainly appropriate, but at the local level, these adverse impacts can be quite important, and certainly not something to be ignored. One county's gain is certainly not another county's loss, that type of thing. Secondly, I think traditional benefit cost analysis yields market projections which are not forward-looking, if you will. We seem to do a fairly good job of predicting activity in the short run, or expected activity in the short run, up until about 5 years. You get beyond 5 years and curves don't seem to fit as well. Standard errors certainly don't go to zero, especially when you get into 10 or 15 year scenarios. After that, of course, there's a large problem. We need to address this forward-looking aspect of markets. The reason for this, the reason for the lack of forward anticipation, of course, is that an integral part of benefit analysis involves identifying social values, and these social values change over time. In fact, they change slowly over time. These are not going to be captured in an ex-ante sense. These future value shifts are certainly not reflected in water prices or currently observed water prices. Who would have thought, for instance, 15 years ago that we'd be standing here today talking about in-stream flow allocation? It's equally speculative to take a guess about what we'll be discussing 15 years from now. So the forward-looking and area of origin concerns are certainly something that have to be amended. The third reason, and I think which is probably largely responsible for the first two, is the type of value associated or generated by in-stream flows. Flowing water has values which are not transmitted through organized markets. In fact, they're not transmitted through simulated markets. The total value of water, flowing water, is composed of both commodity and non-commodity aspects. It is this component, this non-commodity component of water, flowing water value, which is critical and is certainly not captured in traditional or standard benefit cost analysis. This is the issue of in-stream flow. I do think this is the critical issue. If water, the idea is strictly a commodity, as apples or oranges or anything else, and there's certainly some recent legal decisions to indicate that's the case, or at least the courts seem to feel that way, then it has presumably a demand function, which can be derived or estimated, either by asking or soliciting willingness to pay indirectly, or some direct demand function. We can then derive or generate a price for water, presumably, then estimate changes in consumer surplus whenever we perform a reallocation, and the resulting impacts to social welfare. In this traditional scenario, water can be allocated by relying on these prices then to transmit the total value of water. Unfortunately, it's not at all clear that in-stream flow values can be measured by price. Again, these are not commodity values flowing through markets. Water may be a good in the economic sense, in the sense that it yields a sense of satisfaction. You can individuals derive utility from it, but it is not entirely a commodity in the traditional sense, in the concept of production theory anyhow, and it is certainly not a commodity produced for sale. These values do not accrue only to recreationists and fishermen either. These values impact upon all aspects of Wyoming society. And we need to develop a framework that addresses that as well. Also, these values are more likely to be more important at the state and local level, especially in terms of the forward-looking market and the area of origin concerned. Okay, to make up it's likely the non-commodity aspect of water is likely to make up a large portion of the total value of water at the local level, although the commodity aspect is certainly important. Now, before we go into these values directly, putting out a list of these values, I think it's first best to outline the general theory of economic allocation of water in terms of efficiency and prices. And that theory is generated by the idea that all values of water can be priced. If this is the case, we have a minimization of problems and conflicts. Then we can look and see where in-stream flow values fit into that general framework and the type of problems that it causes. I've found that this is usually the best way to go about this. Let me slide this on here. Okay. I think we can get most of it. All right. Now, the standard theory upon which traditional benefit cost analysis is based assumes the following about individual behavior: that only individual preferences count, that the information needed and or required for water allocation is good information, it's cheap to acquire, all resources are divisible, they're mobile, and market participation is completely open, no barriers to entry or restrictions. Individuals in this scenario are portrayed as being autonomous, self-determined, and rational maximizers of well-ordered preference sets. In other words, no non-convexities in these optimization scenarios. When this is the case, if individuals do or can be characterized in this fashion, then a water market, what we can refer to as a water market, is distinguished by water values, first of all, which are distinct from land values or any other value attached. In other words, you have to be able to value that water distinctly and not include it as just a part of the total land value. There also has to be a condition of voluntary reallocation. No one's forced to make this transfer in use or forced to carry on a negotiable transfer either by courts or legislation or otherwise. Also have to have complete negotiability on the part of all parties involved. When these characteristics are present and we have a water market, then we can look at the allocation criteria. First of all, there has to be complete flexibility in transfer of water from one use to another. There can't be any barriers to that flexibility. The flexibility must also be consistent with security of tenure. In other words, once you obtain a water right, no one can take that right from you or petition for a change in use without some type of cost involved. Complete opportunity cost simply refers to that all costs involved in the transfer are accounted for. That includes collective values or social values, values held by the community at large, rather than just individuals. Predictability simply refers to the fact that we know what the outcome of a transfer will be. In other words, we don't reallocate water and then sit back and we're all surprised by what happened, and there was anticipations. No one anticipated anything otherwise. Equity: these transfers or reallocations have to be completely equitable. No third-party impacts, no externalities, that sort of thing. Again, standard, what it really is a standard theory of commodity allocation. Same conditions hold. When all these features are present in a market system, we can then take a look at the efficiency criteria and the standard economic efficiency criteria found in benefit cost analysis, and that is that all agents are characterized as engaging in price-taking behavior, no monopoly power, no coercion in that respect. Complete information is available to everyone. No one's surprised by any outcomes. No one is shocked by the lack of information, so on and so forth. Property rights have to be both complete, well-defined, and comprehensive. They have to address all private property issues involved in the water transfer. And complete transferability, meaning that this water or allocation of water can be transferred immediately into another use or between uses or in any other such fashion. There's no restriction upon the transfer of those uses. When all those conditions hold, when the allocation conditions hold and the efficiency criteria are met, we then obtain what can be called some benefits, or we can realize some benefits of this water marketing scheme, which can be characterized in the following fashion. When these criteria are met, a competitive market will be formed, okay, and only in that case. This market will be responsive to all demands. If someone petitions for water to be placed into a different use, whether it's a higher valued use or a lower valued use, there's nothing restricting all agents to negotiate, all agents' ability to negotiate price and quantities. Equal marginal values across uses. In other words, there will be no incentive to reallocate simply because water is in its highest use, and there's no restriction in allowing water to move to a higher use, and no incentive to do so since it's already there. When this holds, we will have long-run and short-run investment opportunities generated simply because there's been a reduction in uncertainty and expectations are realized, all states of nature are realized. Real opportunity costs have been accounted for. In other words, no cost has gone unnoticed, including social cost or including collective cost, if you will, no externalities, no third-party impacts from this transfer. At least no third-party impacts in terms of market fairness. In other words, the losers have been compensated if there are any, and water is allocated to all of its highest uses. When all this holds, when the allocation criteria and the efficiency criteria and the benefits of water marketing are realized, then no improvement will be possible on the general situation simply because there are all optimal conditions in all aspects of allocating that commodity. What we have here then is just a straightforward pricing scheme for water. It is argued that in water markets, if this type of market exists in the West or in Western states, then we can simply look at the price of water. That price will reflect the value of water, which is the same type of concept that applies to any commodity. Again, there has been some recent legislation that does seem to support that. Unfortunately, things don't work out this cleanly. There are a lot of reasons, and the literature is full with articles of why price or market price or the observed market price for water may not reflect the total value of water. And what I want to do is put up a list of, a partial list of some of the factors that can prevent the price from conveying the total value of water, the observed price or the observed market price. First of all, we have physical constraints of supply. Water is a stochastically determined resource. Its supply is uncertain. It evaporates, it evapotranspires, it seeps. We're not quite sure on how much is going to be there tomorrow, flood one year, drought the next, so on and so forth. The best we can do is assign a probability distribution to that. There exist economies of scale in water allocation. Quite frequently, the first units of water allocated have a very low value. However, that value tends to increase at a rapid rate as we build larger and larger water projects or storage projects. Jointness in production and consumption refers to the fact that water is both at once a source of utility or final consumption utility, and at the same time it can serve as an input to production. In standard economic theory, this causes all kinds of problems. There's been a lot of literature in the industrial organization area addressing jointness in production and consumption. We don't need to go into it in any detail here. Public good characteristics, issues of rivalry, exclusion, these are all important with flowing water. Again, probably too many to list or to get into detail about it would probably take too long. Necessity of life, the fact that water is a necessity for both livestock as well as people, and oftentimes you're in a position where the price of water is really irrelevant if you need some to drink or you need to water your livestock. Interdependencies among users refers to the fact that externalities can arise and you can have third-party impacts or impacts from upstream users can accrue to downstream users. Downstream users are certainly not independent of upstream users. Transactions costs tend to be high in allocating water, as do transportation fees when you want to transfer water between uses, certainly higher than estimated marginal values of water. Again, tends to prevent perfectly competitive markets for water from forming. Imperfect property rights. There are typically third-party impacts anytime you reallocate water between uses. Imperfect competition. Usually when you enter into a large storage construction project or a major reallocation project, you have the conditions of a natural monopoly are usually present in that respect. Intervention by policymakers, a lot of politicking goes on when reallocating water. Sometimes that intervention is not done in order to derive, for instance, a more efficient benefit-cost ratio. There are simply other issues going on there. Public interest and public trust doctrines, these are becoming more prevalent today, especially in Montana. The state of Montana is a good example of that. As the public interest involved or accruing to flowing water tends to be far more important. I think the major issue up there was whether you could send a raft down a river through a rancher's property. And it brought up this issue of whether the river itself is owned or attached to the land, or whether it's part of the public endowment of resources. Anyhow, this is likely to increase in the future, this focus on public trust. Non-market organizational failure. A lot of times the allocation of water is in the hands of community organizations, water conservancy districts, boards, directors, so on and so forth. It's not clear that these directors or boards act in the same fashion as corporations do, for instance. They may not be as efficient in allocating water in this fashion. Let me slide this up here. Okay, economic value constraints. Typically the value of water at the margin, as estimated in most of the literature, tends to be very low. It's held by some researchers that this is a reason why these economic markets don't form readily, simply because it's not economic to do so. And until water is priced higher at the margin, there's simply no incentive on the part of districts to provide legislation which supports these types of markets from forming. Where are we at here? Federal policies. I don't think we need to say much about that. Everything from interstate compacts to pollution control laws, so on and so forth, can have an impact on the price of water or the price of water in its current use. Misconceptions on both the part of the public as well as policymakers, economists, and all types of individuals and organizations. Quite frequently we read about an exaggerated importance of water in developing the West. Much more is attributed to water as an input for development in western states than probably should be. Again, this differs depending on the situation involved, but there's no end to the hype in some cases on the importance of water development, even when it's abundant. This doesn't just happen during drought times. Native American claims becoming more important every day. The problem with most tribal conflicts here arises when the reservation was granted the water rights long before they put that water to beneficial use. And recently, when reservations begin to put this to use, it causes all types of conflicts. Most of the literature in this area, the research that's been done on Native American claims, points to the idea that, contrary to popular belief, this was not an oversight on the part of the federal government or a lack of foresight when these reservations were created, in the sense that they didn't know what they were doing when they granted these minerals and all this water to the reservations at the time, having no idea it would become this scarce in the future. This is certainly not the case. In fact, considerable congressional debate went on at the turn of the century, concluding that in most instances that the mineral rights and the water rights simply had to be granted along with these reservations in order to keep them from becoming valueless parcels of land in the future. In other words, we didn't want these reservations to not have their resource rights. That brings us to in-stream flow values, and we could go on with a lot of other points. I'm sure I've left some out here, but I think what we can see here before we start talking about in-stream flow values specifically is that these observed market transactions that we see allocating water from one use to another are probably of the nature of administered trades, more so than market or competitive market transactions. Administered trades where the prices, quantities entry conditions and information available, are controlled socially by government bodies or community organizations or other social agencies rather than market trades where society merely enforces the rules of the game. So it's probably closer to describe these prices as administered prices rather than competitive prices. If you want competitive pricing in water, you probably have to deal with one, if not many, of these separate issues involved. Not clear how we can do that. Now, in-stream flow values. Let's go ahead and talk about these. Again, in-stream flow value is just one reason that the price may not equal the value, or the total value of water may not reflect that. In fact, it acts to drive a wedge between that price and the value of water. Fewer constraints you have, of course, the closer the price approaches its value. Now, in-stream flow values, one of the big things to keep in mind here is these impact not only upon recreationists and fishermen, okay, or livestock watering if you run through the in-stream flow permits in Cheyenne. That seems to be a major emphasis. But all types of individuals, communities, and all sectors of the economy are impacted by in-stream flow values. They can be positive or they can be negative. They can be benefits or they can be costs. They do not just accrue to environmentalists or kayakers, if you will. They can have, in this list, each component can have a portion that's made up of a commodity value and a portion that is a non-commodity value. It is not the commodity value that we're addressing today, but the non-commodity components. And certainly these are not distinct values. There's a considerable degree of overlap involved here. They can apply, for instance, in some basins and not in others. They can apply to some streams and not others, at some times and not at other times. In other words, they can be quite pervasive to nail down, very difficult to quantify. Another thing that we want to emphasize here is that none of these values have really ever been measured. There's been discussion about them in the literature. Very few, if any, attempts to model these values in that respect, and we're simply hypothesizing that these exist. We're not going to assume that they're zero, but then we're not going to assume they amount to a tremendous magnitude either, since it's not clear. No one's ever measured this, so we don't really know. Community social values. These have been written about a lot, particularly in the southwestern states. Past research in this area indicates that community decision-making in water management accommodates and reinforces the cultural unity in that area. Often, the local water organization is a very powerful political group within the community, certainly exercising a tremendous degree of influence on allocation. It can impact upon long-run growth patterns, capital formation markets, or capital formation in capital markets in those areas, output patterns, so on and so forth. These are especially important in local rural communities, local or rural communities, where a river or a stream is a major geographical feature. Much has been written from Western novels to history books of the West, emphasizing the so-called river culture, if you will, and the importance or the identity that the community members have with that flowing water. Conflict resolution and long-run expectations. Just by the very fact that you solve one of these conflicts generates a value to the community in the sense that it creates some degree of certainty about the future, what to expect in the future. Expectations can be realized. It allows for social and community planning in a more exact fashion. Wildlife habitat improvement. Again, just emphasizing the point that in-stream flow values don't accrue strictly to fishermen or impact strictly upon fish populations. There's no reason to believe that we have to rely solely upon the impact of fish to value in-stream flows. The in-stream or the stream itself is an entire ecosystem, and we have to look at the impact of that ecosystem, not just the fish. Greenbelt values, only a couple studies in this area estimating the magnitude of greenbelt values. They can accrue to both the agricultural community. In fact, it's always a source of amazement to me why every time we evaluate a proposed reservoir or dam, we never include the benefits of greening up a particular basin or river area or irrigated area. Certainly, greenness has a value in the West and always has historically. This can also have a commodity component, can impact on local land values, the fact that they remain green or the river remains flowing and creates this type of growth. Intergenerational bequest, I'm not clear on this one myself. I throw it in there just to mention it. It can refer at one minute to the idea that the state may want to set aside a certain portion of its flowing rivers for the benefit of future generations or future residents of Wyoming. At another time, it can refer to the idea that families or individual ranches and farms may want to assure that there's no loss of value accruing to that ranch or farm, and making sure they can pass that value, that total value, onto other individual members of the family. Substitution and complementary impacts. Substitution is vaguely understood. We're not quite clear on the impact of adding, for instance, a recreational site or a free-flowing river, keeping a river free-flowing in a basin. We don't know what the impact of that will be in terms of substituting away from use at other sites and vice versa. Studies are just beginning to merge in this area. Usually they're random utility models, multinomial logit-probit type specifications, and the results are not completely in on that yet. Complementarity values are even less understood. This is really, you can see this type of impact in communities, for instance, that place a lot of emphasis on generating golf courses, ski resorts, this type of thing, where it's argued that if we don't have an absolute number of ski resorts, more ski slopes, more golf courses, we won't be able to compete with other resorts, in which case each river, in this case, or stream, is a complement to the other streams rather than automatically assumed to be a substitute. Anyhow, these obviously need more research. Economic diversification, to the extent that tourism depends on recreational opportunity. Certainly there's a value to communities being able to diversify by providing more tourist opportunities there, no question on that one. Residential experience values is something I call residential experience values. This relates to the wealth constraint that is generally assumed in all economic evaluations. We generally take the individual's income as given, exogenously determine his wealth endowment is exogenously given. There is a residential value to living in a state that provides a certain amount of environmental wealth, if you will. For instance, if you're a fisherman, you are a far wealthier individual living in Wyoming than you are, for instance, living around Detroit or someplace like that. Whenever the state or any community decides to take action to alter the quality of any site or any in-stream flow, you in effect impact the individual budget constraint. You are affecting my wealth endowment, and it's not clear how these endowments change whenever these sites are impacted or changed in any way. Anyhow, that's an issue that needs to be looked at. The rest are sort of physical impacts, pollution control and abatement. Sometimes there are gains to pollution control from allocating water to a non-use category rather than a use category. Again, maybe not, depends on the basin and the situation. Downstream supply enhancement where it's appropriate. Groundwater recharge, again, where that's appropriate. Option existence and other non-use values. We throw that in there just in case we forgot some, or there's some that you can think of that we haven't included. There certainly probably are some impacts which may be use values or classified as use values to go along with that. These can include long-term declines in land values from dewatering a stream, erosion of local tax bases, flight of labor and capital, so on and so forth, declines in community wealth, that sort of thing. These are the type of impacts that are involved with in-stream flows. Again, in-stream flow just being one component that may drive a wedge between the observed market price of water and the value of water. So as you can see, it can be somewhat complex. The point is, if proposed dams or reservoirs which maintain or are built for maintaining or proposed for maintaining in-stream flow are evaluated without counting these non-commodity benefits, then they will be undervalued simply because you didn't include these. Likewise, they can be overvalued if you do not account for any potential loss from eliminating a free-flowing stream. Now, let's go ahead and look at the in-stream flow law in Wyoming. I assume some of us are familiar with this and some are not. The in-stream flow is recognized as a beneficial use since 1986 in the state. There is a confusion among most people as to whether we're talking about river systems or entire streams. The in-stream flow law addresses only river segments. In other words, while there's a difference between maintaining an in-stream flow and maintaining a free-flowing stream, this is not a wilderness or preservation type act. This is an act strictly for maintaining a flow. In other words, it is quite possible and logical to build reservoirs and dams to do so, to maintain that flow, evening out or reducing the variance of the quantity of flowing water. So only indirectly does this address free-flowing streams. Only the state of Wyoming can acquire an in-stream flow right. As individuals, we cannot apply for this. Probably the major thrust of the act is that the in-stream flow right is not to interfere with any other existing rights. And while this is the thrust, if you read through it, this is the thrust, it's nevertheless confusing in some areas. Senior rights are mentioned specifically throughout the law. Junior rights seem to be only alluded to. In fact, Section 109 specifically seems to indicate that any existing right cannot be impaired by the allocation to in-stream flow. Again, most of the rest of the law only addresses it in terms of senior rights. And this is probably something, an ambiguity that's going to be dealt with in the future, I'm sure. Let's see, what else can we say about this? Direct flow or storage water. In-stream flow can be appropriated from directly flowing water, or again, it can be taken from an existing reservoir or a new reservoir. You can construct, the state is allowed to construct a new reservoir for the purpose of maintaining in-stream flow. The only benefits from in-stream flow mentioned in the law accrue to recreation and fisheries. And again, it's totally bypassing any non-commodity and even some of the commodity components that we mentioned associated with in-stream flows. Feasibility studies are required, usually initiated by the Game and Fish, who recommends a stream for in-stream flow appropriation. A review process is required involving the Economic Development and Stabilization Board, who determines the need to regulate or estimate damages to fisheries or other senior rights. Again, it's rather ambiguous as to whether or not the evaluation is to occur with any right or not. One constraint to in-stream flow appropriations is that no water is to be appropriated to in-stream flow such that the result is more water flowing out of the state than is allocated to other states by interstate compact. In other words, we don't want to lose that opportunity cost there. Again, the legislation directs the Game and Fish, the WDC, and the Economic Development and Stabilization Board to perform re-evaluations of in-stream flow values, usually on a seasonal basis, to try to determine how much is required, how much of the flow needs to be augmented based on the seasonal runoff or snowpack. So that's going to occur on a regular basis there. Okay, in-stream flow applications in Wyoming, just to give you an idea of what's being done and the increase in this area. These are the flow applications that have been received. The first three have been approved. they represent approximately 25 miles of stream segment. The remaining applications, depending on how you interpret them, can represent anywhere from 75 to 100 miles of additional stream segments. Laramie River being local here, of course, is very recent. And so you can see this is going to be a growing concern in the future, given that there are not that many available unappropriated surface water supplies. So these conflicts are likely to increase somewhat. Now, if you're going to model, you know, the first thing that most people say is, well, this is all fine and dandy, but can you do anything in the way of modeling or allocating these in-stream flows in terms of their non-commodity benefits? We don't have a whole lot of problem modeling the commodity components, but the non-commodity components can be a real problem. First of all, the model must include all benefits and costs in the impact upon all existing water rights. We have to build a model that's consistent with the law. We must evaluate, the law requires evaluation of both long-run costs of providing an in-stream flow appropriation as well as short-run adjustment decisions or impacts. We must also account for the stochastic nature of the resource. We can't assume that X amount of water is going to be available next month. That is never a certainty. The modeling of this situation probably demonstrates the problem every bit as much as it solves the problem, and that is, it points out that if you can price all the components of water allocation, we'll be in good shape. But if we got non-commodity values, we need to do some amending here. Now, here's what I want to do is just, in the remaining minutes here, I want to just put up a simple model, a general framework for allocating in-stream flows, trying to remain somewhat consistent with the statute in terms of long-run in-stream flow levels, which are to be determined, short-run adjustment levels, the short-run forecast, and the actual supply augmentation, the actual amount of rainfall or runoff that we receive. This model is a very general framework. It's been used very often in natural hazard events. Everything from floods to tornadoes, earthquakes, and in this case drought is what we want to apply it to. It consists generally of a short-run decision rule, a formulation of the damages in both the long run and the short run from leaving water in stream, a probability function which relates events in forecast so we can capture that stochastic nature that we're talking about, and finally an objective function and some type of optimality condition or optimal allocation condition. Okay, in this case, we can conceive of a decision rule in the short run there, of course. Y will equal 0, or we will do nothing if the forecast is for lots of rain. Obviously, a greater proportion, alpha, than is required to maintain that in-stream flow. On the other hand, Y will be a function if the forecast is for a deficiency. Alpha, in this sense, being the trigger, or when we decide to react, that point we decide to react at. B, or beta, will be the strength of the response, how strongly we react to that situation. Damages will be 0, of course, if we have lots of runoff, R greater than X. Damages are a function of long-run damages. If R is deficient, the actual runoff is deficient. But we guessed wrong about that if the forecasts were not that accurate. Thirdly, damages will be a function of both long-run and short-run adjustments if the runoff is deficient and we know about it ahead of time. Okay, if our forecast or our actual information is accurate. We need a probability density function that relates events to forecast, a joint distribution function, if you will, just the odds of being able to predict the actual amount of runoff. Again, the problem here is that you have to assume history repeats itself. The only way to generate this type of a distribution is to look at historical climate data and try to detect some pattern in there that we can rely upon in the short run. Hope that markets are forward-looking enough to rely upon this. We have a long-run cost associated with allocating water to an in-stream flow. The reason we want to set it up this way is because if you read through the public hearing and the testimony given, recorded testimony anyhow on in-stream flow applications, the largest concern expressed by the state officials, public officials, is the concept that you may be locking up this flow which was previously unappropriated and therefore denying some type of future growth impact. And so indeed we want to capture that. We also have a short-run expected cost. The expected short-run cost is a function of short-run adjustment, that beta function hit by the odds of the state of nature even occurring. So again, we want to capture that stochastic nature of the forecast in the short run. Okay. Total damages then, total expected damages, will be a function of both the long run and the short run adjustment levels in response to actual supply augmentation, in-stream flow appropriation X, and the short run adjustment level Y. In other words, we can formulate an objective function where we're minimizing what amounts to a sort of expected cost plus loss, okay, a least cost plus loss, and it kind of demonstrates the generality of the this type of framework. Okay. Now, just to wade through a bunch of details, I think we can summarize the necessary conditions. And what they do is really it demonstrates what happens when you try to attach a price to all values accruing to water here. And what this generates is that the adjustment to the in-stream flow level, or the level that is to be determined in the long run, the cost of doing that at an optimum should be equal to this first bracketed expression here is the rate of reduction in the cost of short-run adjustment. The second expression is minus the increase in damages to other sectors from fewer short-run adjustments. In other words, if you allocate more water to an absolute in-stream flow level, you're necessarily going to cause problems in other sectors more often. This final bracketed expressions, these two lines here, are the direct rate of reduction in damages from a less frequent drawdown below X, or that in-stream flow level. Now the second part, or the second interesting condition here, is with regard to alpha, that trigger level. Okay, when alpha is adjusted optimally, this turns into an inequality. This first bracketed expression up here with regard to X, the in-stream flow level, will drop out. You're left with simply the standard result here, and that is that the marginal cost of providing in-stream flow, C1, will equal the direct rate of reduction in damages to all values outlined earlier. So we can see in order to solve that allocation, we need to come up with some value for those damages or those non-commodity aspects that we were talking about. If we don't do that, we're not going to generate this type of optimality. And again, we have to make the assumption, we've got to make some assumption about these distributions so that we can either assume history is going to repeat itself or place more resources into forecasting runoff or rainfall. Now, to estimate this system, you can estimate this system. What you have to have, of course, are the cost functions. Okay, you have to have the long run and short run adjustment levels in the basin in question. Again, it may be easier to estimate these cost functions than to estimate welfare or social utility impacts, which are not well defined. It just may, we do know several production functions that may fit the economic activity in the basin. Only leaves you with a choice between increasing and decreasing returns, rather than specifying some type of social welfare function or utility function. You also have to have, of course, the historical data, or choose some arbitrary distribution. The gamma distribution has been used a lot in these types of natural hazard events. Again, probably better for the short run than in the long run. And I think that's reflected in the in-stream flow law, necessitating frequent reevaluations of this in-stream flow level. Okay, this type of a model, of course, can be used to evaluate in-stream flow permits received by the state or request, seasonal reevaluations in terms of adjustments, or how much water in a reservoir to allocate. to existing or to in-stream flow, how many rights to purchase on the part of the state for in-stream flow purposes, or whether to build an existing reservoir or dam for the purposes of maintaining an in-stream flow. Okay. Again, I think what we're looking at here is probably the futility of using the traditional benefit cost framework to evaluate in-stream flows. As you can see, when it cooks down, you have to apply a lot of assumptions to boil it down to where marginal benefit simply equals marginal cost. This is only possible when you can price all these aspects of water. If you can do that, if you can price these social values, you'll be in pretty good shape. The problem is, of course, how much is a unit of social unity worth, or a unit of greenbelt value? How much is that worth? And this points to the real problems with using traditional benefit cost analysis. In conclusion then, just to summarize this, it's clear that the concept of economic development when applied, economic benefit when applied at the local level needs to be broadened to include these impacts, or all impacts, social or otherwise, arising from a reallocation of water in use or allocating water to in-stream flow. We simply cannot ignore these types of impacts or imply that they're zero. If these values are positive, and it's totally unreasonable to assume that they're equal to zero, then we need to include them in order to determine an economically appropriate or economically efficient water allocation among uses. If they're positive, again, we don't know if they are or not. They may be insignificant. If they are, we can ignore them and move on to just a commodity pricing scheme. Again, since it's never been measured, we're not really able to make that definite conclusion on this. And finally, I think we can ask the broader question here, the more general issue, is why, as economists, do we feel that it's absolutely necessary to base the decision on whether to reallocate water, whether to build dams or reservoirs, or whether to designate water use? Why do we have to base that decision solely on monetary benefits and costs? There is no universal law that requires this. In fact, if you go through all the literature, everything from public hearing and testimony to state statutes, we find the only recommendation for this type of framework is the suggested federal guidelines. And as we know, the feds aren't paying the bills out here the way they used to. In other words, we have to incorporate a measure of benefit that goes beyond some monetary value. And I think this is borne out in most public water hearings. Every time a project is proposed, we start off deriving nice feasibility studies and benefit cost analysis and generate lots of BC ratios. And, you know, by the time these things are over, 5 years down the road, everybody forgot what the benefits and costs were anyhow. And we're usually arguing about something else involved here. And we have to ask ourselves as economists why we do not allow these types of normative decisions that in effect actually do go on to guide us in determining whether or not we should build a proposed water project or dam to maintain in-stream flow. Again, there's absolutely no reason why not. Probably time to start recognizing that these social values exist and make some attempt to evaluate the impact these values have upon communities and counties and individuals in the state. Okay, that's about all I have to say. If you have any questions, I'd be happy to address them. Comments?
I was wondering if anybody done any type of cost analysis comparing groundwater storage, surface water storage costs versus development of groundwater, which is already in storage basically in the groundwater. With
regard to in-stream flow? Is it?
Yeah, well, just
It's
yeah.
more beneficial cost-wise to spend the money on developing the surface water storage and maintaining the stream flows rather than just leaving things naturally and pumping the groundwater that's nearby and things like that.
Not that I know of. I really have never seen. Again, the only literature in in-stream flow, I think you can cook it down to about 3 articles that have ever even been written on it. Most of them are qualitative, normative in nature, They don't really, certainly never a benefit cost analysis of doing that hasn't been performed that I'm aware of anyhow.
It seems like the value, the price problems that you were talking about would be more easily solved with the groundwater, since you aren't dealing as much with the aesthetics, the recreational.
Yeah.
It would just be simply
Oh,
pumping costs and
Yeah.
production
Yeah.
capacities and things like that.
I would agree with that. If the groundwater, if the basin or the stream segment in question is a matter of groundwater, I would agree with that. Problem is, it's not always going to be that. A lot of these issues are going to come up with surface water or flowing water. Certainly, if you could, if it's a situation where groundwater is the major source of supply augmentation, then that would solve a lot of problems. But unfortunately, that's not always the case. Yeah, I would agree with you if that were the situation, and it probably is, probably will be in some future applications. But currently, it doesn't seem to be the issue in too many of these applications. No one's applied for that specifically, so probably in the future that issue will come up, yeah. Obviously, groundwater pumping would be an option. Yeah.
You've pointed out a number of reasons why there's trouble valuing the water. As an economist, are you saying that we should use non-quantitative methods for our resource allocations?
I'd stay away from the word should, but yeah, I guess what I'm saying is not that we should, but we already do, I guess is what I'm saying. What I'm saying is if you look at most water proposals, most storage proposals, for instance, the debates on these things rapidly leave the realm of feasibility studies, efficiency criteria, and benefit cost analysis. Usually these end up to be highly political debates. And I think the issue is not whether we should allocate water, based on political or normative grounds of that sort, or should not. I think we actually do, and I think it's time that we recognize that we do that, and that this has happened in the past, likely to happen in the future. It's very doubtful we're ever going to get to a point where we can kick out a benefit cost ratio and let that stand on its own and make a decision one way or another just based on that benefit cost ratio. Given the cultural history of the West and developing water supplies, and certainly the rich historical literature on the importance of water in the West, it's very doubtful we'll ever get to that point. Maybe that would be desirable if we could price all aspects of this, generate one benefit cost ratio, one discount rate that everybody can agree on so that we can say, okay, that's it, let's go build it. I think that would be wonderful. I just don't think that's ever going to happen simply because it's really never happened in the past. I can't think of an instance where a reservoir was ever built strictly on efficiency criteria. There always seems to be a lot more going on. With the exception of severe water shortages, areas in the Southwest where municipal demand, for instance, sometimes these become absolute necessities to build these projects. There's very little discussion. Again, even then, there's very little discussion of benefits and costs. Simply, it's a necessity of life and has to be done. I mean, again, I don't think it's an issue of whether we should. I think this is what we do. And I think until that changes, then we need to recognize that this is the process that goes on. These type of normative judgments are made all the time. And I wonder sometimes as economists why we tend to deny that. And we either we wish it didn't happen or we'd not like to see it happen, one or the other. But I think it's wishful thinking in that respect. Hopefully someday we could get to that point. Hopefully someday we can expand the traditional federal framework to a point where we can just rely upon the result generated by that framework. That'd be wonderful. Again, it's going to be awfully difficult to price these other types of non-commodity values that accrue. And I think there's nothing wrong with taking a look at what they mean at the current time. That methodology is just not available yet.
The Water Resource Council guidelines already incorporate a number of methods for non-market valuations, though.
Well, I think CVM is probably about the only one that's moving in this direction. CVM, however, relies upon a willingness to pay estimates. A lot of problems with CVM. First of all, the results you receive from a CVM are directly related or a direct function of the question that you ask. You ask somebody their willingness to pay for a non-commodity, for instance, you have to make it clear if you're asking that before they got their electric bill in the mail that month or after they got their electric bill in the mail that month. A lot of studies indicate that they're very sensitive to the question you ask. They're also directly sensitive to the amount of information the individual has. Given an individual an increment of information, he very likely will change his estimate. And then there's even the broader issue that willingness to pay is usually conducted from an individual standpoint. There is no reason to assume that individual willingness to pay is going to capture any social values or collective values. There's no reason to believe that individual decision making will internalize social aspects of value. CVM is promising, but it needs a lot of work in those areas. Again, you've still got this fundamental problem, though. You are estimating willingness to pay through a market, organized or otherwise. The market in this case is simply simulated. You're simulating a market. You're asking people to put a price on everything from cloud formations to flying butterflies, and that's just simply not possible. Individuals are not familiar with those types of commodities in the marketplace. Certainly violates most of the reference.